Alright, let's take a look at review problem 4.1. First off, let's find the 5 statistics summary for this data. That's shorthand for saying I want the average of x, the standard deviation for x, the average of y, the standard deviation for y, and the fifth thing is the correlation coefficient. Now to get these things, we will first find a few things. We need the sum of the values of x, the sum of the values of y, the sums of the x squareds, the sum of the y squareds, and finally the sum of x times y. Okay, so let's take a look at these things one at a time. So first off, the sums of the x's. So if I just simply add up all of the x's together, that's 56. And if I add up all of the y's, that works out to be 42. So I'll put those down here first, 56 and 42. And so from these, clearly we can get the average. So the average of x is going to be 56 divided by 7 for 8. And the average of the y's will be equal to 42 divided by 7, which is 6. Now the next things we have to compute are the sums of the x squareds and the y squareds. So let me put a column here, x squared, and another column here, y squared, where I will simply just square all of the x values. So 4 squared is 16, 6 squared is 36, 12 squared is 144. And if I add up the values of these x squareds, I get 664. Similarly, if I add up the y squared values, add up those 7 squares, I get 348. So this is 664, and y squared worked out to be 348. So at this point, we can now compute an intermediate step, which is to compute s sub xx and s sub yy. S sub xx is defined to be the sum of x squared minus 1 over n times the sum of the x's all squared. And let me give myself a little bit more room to work. The sum of the x squareds works out to be 664 minus 1/7 times 56 quantity squared. And so just simply doing the arithmetic, 664 minus 56 squared divided by 7 turns out to be 216. Similarly, s sub yy is equal to the sum of the y squareds minus 1 over n times the sum of the y's all squared. So this works out to be 348 minus 1/7 times 42 all squared. So 348 minus 42 squared divided by 7, and that works out to be 96. Now from this information we can now get the standard deviations. The standard deviation of x, and this is a formula that we saw way back near the start of the course, is equal to s sub xx divided by n minus 1. And so that's equal to the square root of 216 over 6, which works out to be exactly 6. Similarly, s sub y, the standard deviation of y, is equal to the square root of 96 over 7 minus 1. That works out to be exactly 4. So those are 4 of the 5 statistics. The fifth statistic is going to be s sub xy. And this works out to be the sum of x times y minus n times the average of x times the average of y. So the sum of x times y, let's get a new column here, x times y. So that'll be the x value times the y value. So 19 times 0 is 0. And I add these 7 products up. And I get 197. So 197 minus 7 times x bar, which worked out to be 8, times y bar, which works out to be 6. So 197 minus 7 times 8 times 6, which is negative 139. And so our fifth statistic, r, is equal to s sub x at y divided by the square root of s sub xx times s sub yy. So negative 139 divided by the square root of 216 times 96. Now the denominator, I believe, works out even. And is 144. So negative 139 over 144. So something that is quite close to 1. Okay, so, and let me put that in decimal form. So that's negative 0.96527 repeating. And so that's the first part of the question, getting the 5 statistic summary. And one thing I should have wrote down up here, that the sum of the x times y's is 197, which is the number that I used down here when computing s sub xy. Next step is to find the equation of the regression line. Let me clear off the space here. So to get the equation of the regression line, we remember that our formula is that beta 1 hat is equal to r times s sub y over s sub x. And so that is equal to negative 0.96527 bar repeating times s sub xy, the standard deviation of y, pardon me, which is 4, over the standard deviation of x, which is 6. And so that works out to be negative 0.6435. And then 185 repeating after that. I'll just cut it there. Alternatively, this can be determined by s sub xy divided by s sub xx. S sub xy was worked out to be negative 139 earlier. And s sub xx was worked out to be 216. And so if I just simply take 139 divided by 216, I get the same thing, negative 0.64435. So two alternate ways of getting that. And finally, beta 0 hat is equal to y bar minus beta 1 hat times x bar. So that would be equal to 8, y bar is 6, I apologize, minus negative 0.6435 times x bar, which is 8, and so doing the arithmetic, we get that this is equal to 11.148 repeating. And so the equation of the regression line is going to be y is equal to 11.148 minus 0.6435 times x. Okay. Predict the value of y if x equals 10. Well, plug in 10. So if for part 3, to predict the value of x when y, to predict the value of y when x is equal to 10, to do that, we'll just simply let x equal 10. So y is equal to 11.148 minus 0.6435 times 10, so 6.435, just moving the decimal place over 1. And so we do the arithmetic, and we get that that is 4.713. So that's the answer for part 3. Let me move this over to just give myself a little bit more space. So that's part 3. Part 4, you might be tempted to do the exact same thing. Let's let y equal 10 and solve for x. However, that is incorrect. The equation in purple that we see only works if I know x and I'm trying to predict y. Here I know y and I'm trying to predict x. And so I have to reverse the roles of x and y in order to get the equation. So the computations will be quite similar to what we have already. So let me clear off a little bit of space here so I can have room. So let's see. Let me get rid of this. Actually, let's not get rid of that. Let's get rid of some of the stuff on top here. So for part 4, predict the value of x if y equals 10. To get started, we need to find beta 1 hat again, except this time we're predicting the other direction. So I could have that beta 1 hat is equal to not s sub y over s sub x, but s sub x over s sub y times the correlation coefficient r. Or I can write this as s sub xy, the crossing, but I divide not by s sub xx, but by s sub yy. Now using the latter expression, that's negative 139 s sub xy, which is the number we saw here, divided by s sub yy, which is 96. And that works out to be negative 1.4479. And I'll let you confirm that that's the same thing as if I did negative 0.96527 bar times the standard deviation of x, which is 6, divided by the standard deviation of y, which is 4. That's going to be the exact same thing as the thing we just got. Okay, so that's beta sub 1. Beta sub 0 is going to be, well, before it was y bar minus beta 1 hat times x bar. This time it's the reverse, x bar minus beta 1 hat times y bar. So that'll be equal to the average of x, which is 8, minus negative 1.4479 times the average of y, which was 6. And so doing the arithmetic, this works out to be 16.6875. And so our regression line, if y is known and x is being predicted, is going to be 16.6875 minus 1.4479 times y. And so finally, for problem number 4, if y is equal to 10, I would have that my predicted value of x would be 16.6875 minus 1.4 times 10, so 14.479. And so that works out to be 2.2083 repeating. And so that would be the predicted value of x if y is known. The next question asks us to estimate the size of the residuals when predicting y from x. So let me clear off some space so we'll have room for this computation. Estimate the size of the residuals when predicting y from x. For this one, there's a fairly nasty formula for this, so let me write that down for us. And so if the x's are known and the y's are unknown, the prediction formula goes like this. That the magnitude of the residual sigma is going to be equal to the square root of the errors of the sum of the squares, SSE, divided by n minus 2, where the SSE is equal to the sum of the y sub I squared minus beta 0 hat times the sum of the y sub i's minus beta 1 hat times the sum of the x sub i's times y sub i's. Okay, so the information is things we've found before. The sum of the y sub i's squared is 348. Beta 0 is the intercept, which we found to be 11.148 repeating. The sum of the y's works out to be 42. Minus beta 1 hat. The slope of the regression line was negative 6.435, then 185 repeating after that, times the sum of the x's times the y's, which was 197. And so doing the arithmetic, we get that this is 6.5535. And so sigma, the size of the residuals, will be approximately the square root of what we just found, 6.5535, all divided by n minus 2, which is 5 in our case because we had 7 data points. And so doing the arithmetic, the size of the residuals will be about 1.1449. 1.15. Okay, now let's see, does that make sense when we take a look at the data? So let me clear off the information here, and let's just simply plot the data and see if this actually looks right. So if I scatter plot, there's the data, Let me add the trend line. And the equation, I hope, matches what we found earlier by hand. And r squared should match what we had before by squaring the 0.965 figure. And there it is. Now we notice that the size of residuals here is maybe about 1.5 off. Here it's pretty close. That looks about 1 off. This looks like about 1.5 off. This looks about 1 off. So the magnitude of the residuals tends to be on the order of the size 1.15. So that's the meaning of the number we just got. The last part of the question asks, do you think that a linear model is appropriate for this data? Now, the great temptation would be to say yes, it is, because the r squared is so close to 1. But we notice something very subtle. These 2 points are above, the one on the end is above here, while the ones in the middle are all below. That should not happen. In a regression model, it should be basically a 50-50 split as to whether or not it's above or below. Here, there's a definite trend. The ones in the middle are below, the ones on the far edges are above. And so that's a tip-off that the regression model may not be the best thing. And so in this case, just based on the graph, we would say that the linear regression model probably is not appropriate, and we ought to try something else. Okay, now before stopping this video, let me talk about how to do some of these calculations in the calculator. So ahead of time, I've put in the x and y coordinates. There are the x's and there are the y's. If I go to Stat, Calc, 2var tests, and then L1 for the x coordinates, and then L2 for the y coordinates, I get the same information that I got by Excel. The sum of the x squareds is 664. The sum of the y squareds is 348. And the products x times y add up to 197. So a lot of this information can be gotten off a calculator as well as by using Excel, and then we use the formulas as before.